In this video, we are going to be talking about the types of solutions for systems of equations. So if a system has at least one solution, they are considered to be consistent. So notice the word at least here. So that means that it has one or more solutions. It is considered to be consistent. So an inconsistent system would mean that there are no solutions to this. And for a system to have no solutions, that means that they never touch. So these are actually going to be parallel lines. So consistent systems can either be independent or dependent. So independent means that there is only a single solution, where dependent means that there are infinitely many solutions. And for a system to have infinitely many solutions, it means that those two lines are actually the exact same line. They are traveling on top of one another. So they coincide. So some visuals of the different types. So on the first column, you can see that this is a consistent and independent system. It's consistent because it touches at least once. It's independent because it's only touching at one point. The next one, both the blue and the red line are actually laying on top of one another. So this is consistent and dependent. So they depend on one another. They're going hand in hand constantly. The last one is inconsistent, meaning they never touch. So there's no second classification for inconsistent. It just means that they're parallel. So that's it. So let's look at an example and determine what it is. Is it consistent? Is it going to be inconsistent? Is it independent if it's consistent, or is it dependent? So to do this, we're going to start solving like we normally do. So I have a choice between graphing. I have a choice of stop. So I have a choice between graphing, substitution, or elimination. So typically I want to not graph because I don't get to see the points as well. So I'm going to stick to either substitution or elimination when I'm trying to solve these problems. And the thing that tells me to use substitution is because I already have a variable equal to something. So this is a great substitution because now I just need to take this x minus 4 and substitute it in for the y of the other equation. So I'm going to do that. So the second equation is negative x plus y. So I'm going to substitute in that x minus 4 equals 3. So there's nothing being multiplied to these parentheses, so I can drop them. So I see that I have like terms of this negative x and x, so I'm going to add them together. Except negative x plus x cancels. And I'm just left with negative 4 equals 3. And we already talked about this in previous videos. If our variables ever cancel, we have one of two things that we need to check. Is it true, whatever is left, or is it false? If it's true, we get infinitely many solutions. If it's false, there are no solutions. So looking at this statement, we have negative 4 equals 3, which is not true. Negative 4 does not equal 3, so that means that this is no solutions. So again, anytime that your variables cancel, so there's no more variables, you need to check whether or not it is a true statement or a false statement. So since negative 4 doesn't equal 3, there's no solutions. If we had something like negative 4 equals negative 4, then that is a true statement. So that would give us the infinitely many solutions. So how about you guys try one out? and check to see if this has infinitely many solutions or no solutions, or if there is a single solution. So this is a great substitution problem, and you would have seen that your variable is canceled and it was a true statement. So this means that there's infinitely many solutions. So you can also use the infinity symbol, which is basically like a sideways 8, to represent infinitely